happy Monday. Today we are starting out a new unit, Unit 4B. This is all about limits and derivatives, which will be super helpful if you are going to take calculus in your future. The first thing we're starting with is estimating limits of functions at fixed values. So first, as a quick overview, what is calculus? You'll be solving two important types of problems. You might have to find the equation of a line tangent to the graph of a function at a point. So for example, if you had a function, let's just call it f of x, and it looks like this, you will be given a point and they'll ask you, find the equation of this pink line. The second type of problem is to find the area of the graph between the function and the x-axis. So for example, let's say we had g of x is this function here. They might ask you to find the area of this function. So they could make it like from this point to this point, and you have to find that area. Obviously, it's not a perfect rectangle or square since it's curved, so you'll have to use calculus to find the area of this pink shape. For both of these problems, you must know how to use limits in order to answer both of them. Remember, limit means approaching, and we can solve these graphically, numerically, and algebraically. Today we are going to work on graphically and numerically. We'll work on algebraically in a few more days. So we've already talked about limits back in chapter 1 when we talked about continuity of functions. So I'm not going to do a ton of examples here, but I want to go over these and make sure you remember what's going on here. So let's say they said estimate the limit as x approaches 2 of the function negative 3x plus 1 graphically, and support it numerically. So remember, on these problems, you'll first want to plug this function into your graphing calculator under the y equals screen. It will come up with this graph, and basically what it's asking you is as x is approaching 2, so that's what we're showing here on the x-axis, the limit is always asking for a y value. So it's saying, what is happening to the y value? So it's saying basically, what is the y value approaching as x is approaching 2? So if we look at this, as x is approaching 2, we are looking at this function. So as our x value gets closer and closer to an x value of 2, our y value is getting closer and closer to a value of negative 5. And if we wanted to support this numerically, we could go to our table setup. The table start doesn't matter. You can put anything in here. Change in table literally doesn't matter either. The thing that matters is that you have the independent variable on ask and the dependent variable on auto. So we can make this table, type in a few values of x. We want x to be approaching 2, so we could use 1.9, 1.99, 1.999. That would be approaching 2 from the left, on the left side here. We also want to see what's happening on the other side of 2. So as we're approaching 2 on the other side, so 2.1, 2.01, 2.001, we're getting closer and closer to 2. We're going to see what are our y values doing. So we see we're getting closer and closer to probably negative 5. Same thing's happening over here. These numbers are getting closer and closer to negative 5. So what we could say for the answer for this limit, we can say the limit as x approaches 2 for the function negative 3x plus 1 is equal to negative 5. That would be your final answer. The next one, estimate this limit graphically, support it numerically. Again, we're looking as x is approaching 3. What's our y value approaching? So we see as x is approaching 3, our y value is approaching 6. So our x value is approaching 3, while our y value is approaching 6. And if we looked at this on a table, we see as x gets closer and closer to 3 in either direction, our y values are getting closer and closer to 6. So what we would say to answer this question, we'll write the limit as x approaches 3 of the function x squared minus 9 over x minus 3 is equal to 6. Even though on your calculator in this box, it will technically say error. It doesn't really matter for the limit because the graph is still approaching 6. The key word is approaching. It doesn't say that it equals 6. It just says that it's approaching 6. Notice, if we plugged in 3 for this x value, it would give us division by 0. X cannot be equal to 3. X equals 3 is not in the domain. It gives division by 0. But even if the number is not in the domain, it can still have a limit. One thing that we did not touch on very much in Chapter 1 are called one-sided limits. These describe the behavior only from the left, which would be represented with a little minus sign, or from the right, which would be a plus sign. For a limit to exist, the limit from the left and right must be equal. So in order to write that out, you could say the limit as x approaches some value c from the right of our function has to be equal to the limit as x approaches c from the left for the same function. So if these are equal, then the limit as x approaches c for the function exists. Let me give you some examples. So let's say we wanted to estimate the limit as x approaches 0 from the left of the absolute value of 2x over x. Same thing for the limit from the right, and the same thing for the limit, just in general, the limit. So that means both sides. When it doesn't have a plus or minus, it means just the general limit, the both-sided limit. Okay, so if we graph this, here's what you will see. And if you wanted to create a table of values, you could. From the left, we are looking as x approaches 0. Our y values are all -2. We see that in our table as well. As x approaches 0, y is approaching -2 on the left side. So we'll write the limit as x approaches 0 from the left of the absolute value of 2x over x equals -2. However, from the right, if we are inspecting the limit as x approaches 0 from the right, we are looking at this. So we're looking at this point, this point, this point. We see that each of these points has a y value of +2. So as x is approaching 0, our y values are all +2, which confirms in the table. So that means the limit of this function as x approaches 0 from the right is +2. Since the limit from the left is not equal to the limit from the right, this one's -2, this one's +2, that means that the limit as x approaches 0 for the absolute value of 2x over x does not exist. Because as we look at this, as we're approaching 0 from the left and 0 from the right, we're not approaching the same y value, so the limit cannot exist. You can put DNE for this to abbreviate it. Next, estimate this limit from the left and right. This is a piecewise function. Y is equal to 4 if x is not equal to -3, so every other spot besides -3, our y value is always 4. However, when x is equal to -3, our y value is -2. So that's why we have this point down here. You could make a quick table of values if you wanted to. It's not really super necessary. But let's go ahead and work on these limits. So first we'll do the limit as x approaches -3 from the left. As x approaches -3 from the left, we're looking at these points here. All of these points have y values of 4. That means our limit is 4. The limit as x approaches -3 from the right, we're looking at this here. So we're looking at these points. As we approach -3 from the right, these points all have y values of 4 as well. So the limit from the right for our function g of x is also equal to 4. Now remember, we said if the limit from the left is equal to the limit from the right, then that means that the limit for the function as x approaches this number, whatever it is, in this case it's -3, it does exist. And what is the value of this function? Of this limit? As x approaches -3 from the left and -3 from the right, in both cases we're approaching 4. So that means the limit of our function as x approaches -3 is 4. Whatever the value is for the limit of the left and right, it's equal for the limit on both sides. Even though this would fail the continuity test because the limit is not equal to the function value, it still has a limit. Okay, next we're going to look at a few more limits. These are a little different. They're not necessarily approaching a value. So let's say we have this table and this graph. We're looking at the function 1 over the quantity x minus 4 squared. We're looking at as x approaches 4. Notice 4 would not be in the domain of this function because it would give you division by 0. And if we're looking as x approaches 4, our y values are going up on both sides, the left and the right. So remember, in this case, we would say that these y values are approaching infinity from the left and from the right. Even though if you plugged in 4, you're going to get error, we can still say that this limit is equal to infinity. Next, if we looked at this limit of 1 over x as x approaches 0, if we look from the left, we notice that our values are approaching negative infinity. However, from the right, our values are approaching positive infinity. Again, notice x equals 0 would give you an error. X equals 0 is not in the domain of this function. And since the limit from the left is not equal to the limit from the right, this is not approaching the same y value on both sides, this limit does not exist. Your homework for tonight are these problems on page 743. I gave you just a few limit problems to practice since I know you've already done these back in chapter 1. But I just want you to refamiliarize yourself with them and get a few practice problems in. And then number 66 is just kind of an open-ended question for you to try to dig a little deeper. If you have any questions, post them in the discussion board, and I will talk to you tomorrow. Bye, guys.